A 5-card hand is drawn from a standard 52-card deck. Find the probability of the following hands. 4 of a kind. So on all of these examples that I'm about to go through, we're talking about drawing a 5-card hand, so we're going to be using combinations for all of these. This is because we are only caring whether or not we draw the cards. We don't arrange them into any particular order. So if I'm talking about the probability of drawing a 4 of a kind, then the number of ways I can draw a 4 of a kind, I'm just going to keep using N of E on each of these. Hopefully it should be clear what I'm referring to as by N of E on each of them, even though I'm using it multiple different times. Actually, you know what, I'm going to not. Whatever. N of E, the number of ways I can draw a 4 of a kind. I'm going to look at this as two separate choices. First off, when you draw a 4 of a kind, you can look at it as first choosing what rank of card you have. There's 13 ranks, ace, 2, 3, 4, all the way up through king. There's 13 different ranks. And so if I choose a rank, then for each of the different ranks, each of the different rank I chose to do with my 4 of a kind, there's a certain number of ways that I could draw that particular 4 of a kind. So, in other words, I'm going to figure out the number of ways that I could draw a 4 of a kind with just aces, and then a number of ways 4 of a kind with just 2s, and so on. Those are equal, so I can just multiply this by 13. So let's figure out the number of ways we could draw a 4 of a kind with a particular card. Well, from that particular card that we've chosen here, there would be choose 4 ways to draw all 4 of those. And then there's going to be one last card in our hand that is one of the non-ace cards. If this is a 4 of a kind of aces, then I would have 48 non-ace cards that I'm choosing 1 from. So this would be, ultimately, this is just a 1 here. We take 13 times 48, because 48 choose 1 is 48. And we get 13 times 48, which is 642 or 624. N of S, we don't care about it being a 4 of a kind or anything like that. We do know there's 52 cards, and we're drawing a 5-card hand. So this is just going to be 52 choose 5. 52 choose 5 is a rather large number, 2,598,960. So the probability of a 4 of a kind is going to be 624 over 2598960. Let's figure out approximately what this is, because I'm curious. (2.4 times 10 to the negative 4th), or 0.00024. So you're pretty unlikely to draw a 4 of a kind if you're just drawing 4 cards. Now, keep in mind with poker, there's additional rules. You can address things like try to increase your probability of getting a 4 of a kind, but even in poker, a 4 of a kind is rather rare. All right, for 2 pairs, if we're talking about the number of ways we could get 2 pairs, then we have a similar sort of choice here. The number of ways, we need to first decide on what ranks we're doing for our 2 pairs. So from the 13 ranks of cards, I'm actually going to choose 2. This is very similar to this last problem. I just wrote a 13. You could actually think of this as 13 choose 1 if you wanted to see how it kind of ties in with this one. This one would be 13 choose 2. There would be 2 different ways that I'm choosing my two cards that I'm doing pairs with. And then from the first rank, it's a pair. So from the 4 cards in that rank, I'm choosing 2. From the second of the 2 pairs, there are 4 cards, and I'm choosing 2. And so far, these are the cards that I'm drawing. I've only drawn 4 cards, so there needs to be one last card that I draw. And how many cards are left in the deck? There's 44 cards left in the deck. Since 4 of them are taken there, 4 of them are taken there, I don't want to draw. If I had 2 aces, a pair of aces, I wouldn't want to draw a third ace. Or if I had two twos, I wouldn't draw a third 2, because then it wouldn't be 2 pairs. So let's see. This is 6. That's 6. 13 choose 2. 44 choose 1 is just 44. So let's figure out what number this is. 13, choose 2. Oops, wrong button. 13, choose 2, times 6 times 6 times 44 is 123,552. And thus the probability of getting 2 pairs would be 123,552 out of 2598960, which gives us approximately 2598960, approximately almost a 5% chance, 0.0475. And we have a couple more examples here. Okay, to find the probability of a full house. Well, when finding the probability of a full house, there are 2 ranks. So a full house, just in case you're not familiar with it, something like 2, 2, 3, 3, 3 would be considered a full house. This would be 3's full of 2's. So getting 3 of a kind and a 2 of a kind, or a pair. This is what we would call a full house. So the probability of getting a full house, there are 2 ranks of cards that are involved here, and there is a difference between these. If I have 2, 2, 2, 3, 3, this is different from 2, 2, 3, 3, 3. So I wouldn't want to use a combination here. I wouldn't just want to do 13 choose 2 like I did on the previous example. Instead, I could do 13 permute 2 or do 13 times 12. However I want to think of that. So 13 times 12 is, I think that's probably the easier way to think about this. I have 13 choices for the first rank. Let's call that the one that I have a 3 of a kind with. And then 12 choices for the second rank. That's the one that I have a pair of. And given all the number of different ways that I can make those choices, then for the 4 that I have a 3 of a kind of, there are 4 choose 3 ways that I can choose those. And for the pair, there's 4 choose 2 ways that I could do that. And multiply all these together, and that will give me the number of different full houses, number of different hands that have a full house in them. My n of s is still the same number. It's this, it's sloppy. Let me make sure I have the right number here. 2598960. Okay. And pulling up my calculator again. 13 times 12 times 4 times 6. This right here, 4 choose 3. This is just 1 off from 4, so that's how I know it's a 4. And 4 choose 2, that's just, I see that frequently enough that I know that's a 6. So multiply those together, we get 3744. So the probability of getting a full house would be 3744 out of 2598966, which is approximately 0.00144. Alright, the last question with a hand of cards, with a deck of cards here, is the probability of getting a flush. And a flush is, this is what we call getting 4 cards all in the same suit. So n of e, the number of different ways I can get a flush, well, I need to choose which suit I'm dealing with, and there are 4 different suits of cards, so I'm going to do 4. And for each of the 4 different suits, I need to draw 5 cards from that suit. So there's 13 cards in the suit, and I'm drawing 5. So this would be 4 times 13 choose 5, which would end up giving me 4 times 13 choose 5 is 5148. And if s is the same number again, so the probability, this is 52 choose 5. So the probability of E is 5748 out of 52 choose 5. Not 52 divided by 5, 52 choose 5, which is approximately I don't know which is faster, typing in the 2598966 or 52 choose 5, but they're the same number. So in any case, we get 0.002. Oops, I keep clicking on accident. 0.002211. Is that what I saw? Yeah, maybe that should be a 2. So 0.0022 is the probability of getting a flush.